What are the next three terms of the following sequences? So some of these are known sequences, some of them are a little bit of fun, but the whole idea is we're trying to spot patterns. So from here, 1 to 7, maybe we spot that there's a plus 6. 7 to 4, that's minus 3. 4 to 10 is plus 6. 10 to 7 is minus 3. 7 to 13 is plus 6. So continuing that, we need to do a minus 3, which would give us 10. And then a plus 6, which would give us 16. And then a minus 3, which will give us 13 for our next three terms. For part B, this one is immediately a little bit trickier to spot. It's actually a Fibonacci style sequence. If we do 5 plus 7, we get 12, which is the next term. And if we do 7 plus 12, we get 19, which is the next term. And if we do 12 plus 19, we get 31, which is the next term. So continuing that, we do 19 plus 31, which is 50, then 31 plus 50, which is 81, and 50 plus 81, which is 131. So this one's a Fibonacci style sequence. For part C, this one again is a little bit trickier to spot. There is a single thing going from term to term, and it is the rule would be double and subtract 2. So double 3 is 6, minus 2 is 4. Double 4 is 8, minus 2 is 6. Double 6 is 12, minus 2 is 10. So double 10 is 20, minus 2 is 18. Double 18 is 36, minus 2 is 34. Double 34 is 68, minus 2 is 66. For part D, this one is really tricky, and very, very few people ever get this one, but I'm going to write this out as 1, 2, 3, 4, 5. And if you look at the first letter of each of those, you get this sequence. So the next ones would be 6, 7, and 8. Now the next one is even more tricky, in my opinion, but it's related to the one before. If instead of looking at the first letter, we look at how many letters there are 3 letters in the first word, 3 letters in the second one, 5 letters in the third one, 4 letters in the fourth one, 4 letters in the fifth one, then this one is 6, so the next one is 7, which is 5, 8, which has 5 letters, and finally 9, which has 4 letters. F is one that some people might recognize if they have done any computing. It is actually the numbers in binary. So the way binary works is we have 1, and then here we have 1, 2, and 0 ones, and then 1, 2, and 1, 1, which makes 3. And then we have 1, 4, no 2s, and no 1s. So the next one is 1, 4, no 2s, and 1, 1, which is 5. And then 1, 4, 1, 2, and no 1s, which is 6. And then 1, 4, 1, 2, and 1, 1, which is 7. And the final one is a very challenging sequence. It's a little bit of fun. This is a good one to challenge your friends with as well. Actually, these last 4 all are. But this one is say what you see. So what do I see in the first one? I see 1, 1. And the next term is 1, 1. What do I see in this term? I see 2 1s. So the next term is 2, 1. What do I see? I see 1, 2. I have 1, 2. And then 1, 1. So 1, 1. what do I see? I see 1, 1, then I see 1, 2, and then I see 2 1s. So now what do I see? Well, I see 3 1s. I see, oh sorry, that shouldn't be comma there, 3 1s, and then I see 2 2s, and then I see 1 1. Now what do I see? I see 1 3, I see 1 1, I see 2 2s, and then I see 2 1s. What do I see? I see 1 1, I see 1 3, I see 2 1s, I see 3 2s, and then I see 1 1. So that last one is a particularly tricky one to spot, but a little bit of fun. But all of these have a pattern, and that's the most important thing here. In sequences, there's always a pattern. It might be very tricky to spot, but there is always a pattern that enables you to carry on the sequence.